Okay, so I know which question you're asking about. Oh, it's closed. Okay, wait, what is this? Oh, I know. I set off this, I turned it off. No, I don't want to see that. I want to see the exam. It's about the dean. So when you read this question, there is no indication of randomization. Remember, for an experiment, you need randomization, you need replication, and you need control, right? And there's none of that here. All that happened is students registered for classes and he observed. What's the problem with that? The problem is students who know they're good in online courses might take the online course, and the students who need a presential course takes a presential course. So this is a problem known as self-selection, where that can confound your results because they know themselves better, than they know themselves and they know where they perform best. So by self-selection, this is a confounding factor and has not been controlled against by randomization. So this is not an experiment. This is simply an observational study. That is the issue. Okay, Jordan? It seems like if you read between the lines, it's done more scientifically, but it's not. It's just not. And most students get this wrong. But I want to draw their attention to that. It has to be explicitly stated. It just says he assigns the same professor to teach both. Also, there's no mention here of double blindness. So some students chose double blind. There's no mention that the professor knows or is double blind in any way about what he's offering. At the end, I mean, that he's blinded. So double blind is that the students don't know and all the participants are in the research don't know, like the staff. Okay, so this is observational. Any other questions about the test? Thanks for the question, because it did come up with a few students. All right, so we are finishing probability. So you should be done probability this weekend. And this week you're going to begin this unit or module 8 with binomial and sampling distribution of a statistic. Okay. Then you have, I only have 1 week for inference, but we have like 2 weeks to do inference so that the test will be the week after, right? So the 9th. All right. So it's going to get intense. Everything that you've learned is going to be used. We're going to go back and use normal distribution. We're not going to use regression again, but you need to remember regression. We're going to use all the information that you learned about descriptive statistics. So, and mostly centered on talking about normal distributions mostly. So how far did you get with probability? We need probability theory because probability theory is the foundation for what we're going to do next. And So, yeah, how far did you get? You can put it in the chat. Page 30. Okay. So 6 and 7 are both from the same notes, if you were confused. Um, it was the same notes, but it seems like we make a shift, so some sort of shift from probability rules into what do we go into? Then we go into, well, we stay with probability rules, really. The first part is just about the general 6 probability rules. And then I get into rules of means and variances. That's what I spend a lot of time in the second part. And you need that. You're going to need that for the exam. So let's see. These are the notes. So these are the basic rules. I spend some time on those. And the idea there should be intuitive. You should have learned this somewhere or other. And I spend some time trying to separate out the concepts on this like overview page. I talk about complementary events, different from disjoint events, and you should think about these visualizations here, right? Then overlapping events, and there's 2 types of overlapping events I point out. I can separate them. These are just generally overlapping, but then there's overlapping with a special case where the events are independent. And what does that produce? That allows you to know exactly the measure or the calculation for the probability of the overlapping event. It's just the multiple of them. So I try and sort all that out because students come in with some pieces of knowledge and I try to tease it apart. So hopefully that made sense. Then I taught this concept of what probability of A and B is in general. And then we use that. So maybe you've not seen those before, the conditional probability and the idea of the conditional probability. I use this example to describe why independent events, their probabilities can be multiplied to determine the probability of their intersection. So that's just in the beginning. Then I have this last example where I show like the 5th way. So the overview chart shows you the relationship between 2 variables that you can imagine and probabilities of their intersection, their union, not being those events. And then here I talk about an event that is completely contained in another one. So those are like the 5 ways of seeing 2 events interrelate. Then I talk about joint probability here. And count on you getting through all of that. Okay, so then this is really where module 7 starts, but I didn't mark it because it's they're so intertwined, it's hard to separate. So I get into the different kinds of distributions. Broadly speaking, there's discrete distributions and continuous distributions, and I show you some examples of what we do with discrete distributions. The point about discrete distributions is that you can say probability X equals. You couldn't say that for continuous without getting 0, right? So the chance of X being exactly a value for continuous distributions is always 0. But for discrete distributions, we actually have a value and they're finite. There's just a finite set of results. And then I talked about binomial as a special kind of continuous distribution. Oh, sorry, discrete distribution. Introduce you to that. And we're going to spend module 8 focused on calculating the probability for binomials. So This whole page is just an example of identifying a binomial and its parameters. And we're going to spend module 8 talking about how you calculate something like that if you know X comes from a binomial distribution or X is a binomial, random variable. Okay, there's another example. So do the examples. Okay, so this is continuous now. And I tell you that the only continuous distributions we're going to focus on in this class are uniform. Oh, let me go back a bit. I mentioned that there's two other kinds of distributions that, well, I referred to it as unit 5, but sorry. These two distributions, I have some examples on them. I'm not going to test you on these ever. It's just to let you know that there's tons of other distributions with parameters that help describe phenomena like the binomial, but different. So I spent some time like that. They use a similar parameters, P and N, but in a different formula. Continuous distribution. Sorry, I'm just scrolling through okay. So then I arrived here. So what page are we? Okay, so we're still on 20. So let me see the chat. So if you got up to there, that would have been for last week. And then this week you should have gone beyond this. I saw this example, I believe, on the video. This is a really good one. Oh, I think it is. It brings it all together. Because I talk about all the different kinds of relationships. Disjoint, mutually exclusive, independent. Okay. Okay, Christina's page 11. So Christina, you're back there. She's being honest though. So you're back there. Okay, well, you guys got to watch the videos first and then go deeper into the notes, right? All right, so you guys, some of you have a lot of catching up to do. I know the test might have taken some time, but it shouldn't have taken you 3 days. It should have just taken you, if you're still studying, I understand, but the exam shouldn't have taken you even 3 hours. Went over the set of questions. Okay. All right, so this should be review by you, and then all this exercises to practice, 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 lots of practice. And we arrive here. All right. 2. Lisbeth, you said on page 32, this page? You have a question or a different page? Which question 6? Oh, yeah, you told me. The probability of an event A occurs is 60%, and the probability that an event B occurs is 40%. If they're independent, then the probability A occurs and B does not occur. How will you find that? What does anybody have to say about it? Comments, questions?
I believe we might multiply it by the complement of B instead of B. Is that correct?
Yeah, you could do it like that. Sure. I think. Does it work? I'm sorry. Let me, I wouldn't have done it like that, so I have to think. Let me,
It's 0.36.
it didn't work?
Yeah, it did.
Oh, it's 0.36? 0.6 times 0.6 is 36. Yeah, good. Who said that?
Me, Christina.
Christina, thank you. Okay, so that's a way to do it for sure. let me. Right? And they tell you A and B are independent events. So this space gives the probability of A, or we want the probability of A and B. So we know since they're independent, it's probability of A times probability of B. And that is going to be 0.6 times 0.4, which is 0.24. But that's not the question. The question asks, what's the probability of A and not B? So Christina just did probability of A times probability of B. So that is to say, you're assuming since A and B are independent, A and not B are independent. And if you hesitate to think like, oh, is that true? That's, yes, you can hesitate. That makes sense to hesitate, but it is true. And then this is 0.6, and this is 1 minus 0.4, which is 0.6, which is 0.36. So what do we do? What does that mean? It means A and not B is this. So what's another way? Now that I've drawn it, what's another way to get that answer? What's another way to get that answer? Oh, someone's written Jordan. Oh no, he just wrote that one. Okay. Probability of A and not B is just this. So it's actually also equal to right? Okay, so there's not just one way to get there, but there you go.
I have a question.
Uh-huh.
So did the way Christina did do it, would that work with any value, or was it just lucky this time? Like how?
What do you mean? They're
Because she like
independent. They told you.
automatically, sorry?
They told you it was independent. This was the information given.
Right.
So the question is, does it work for any value? Well, it have to be independent, and then it can work.
Got it.
You can't multiply unless they're independent. So the thing out of this one is like all of these are independent. Okay, so if the complement, sorry, if A and B are independent, so are the complements of either of those. A and not B, not A and not B. And but see, I don't think that's necessarily intuitive, so you might have hesitated, and that makes sense. Not A and B. I'll put commas instead of and, so it doesn't look like I've taught you something else. Okay. Okay, good question. Should I continue? Okay. Hmm. Okay, so work on those, lots of homework. All right, then I spent some time here on conditional probabilities. Okay, so some people didn't even get this far. This is not going to be on your exam. I'm going to show you now what I have prepared for you regarding the finals, so you can use your time wisely or efficiently. We all need a little direction. So here in module 9, I don't know why it does that. It opens so large. Here in module 9, at the very end, I have what's called a mock exam. So I have review problems, just like I did for the midterm. And I have a mock exam. It has the same format as the exam I'm going to give you. So the idea should be that you try it without any, well, with limited resources, right? That you try it and write it and get an idea of your strengths and your weaknesses, and you work on those. And it follows, this is the distribution. This is the distribution that it follows. So it's going to be from module 2 to 5. It's going to be 10%. And I say to omit the material here in module 5, which is regression. Remember those pages that I said are not going to be on the midterm and they're not going to be on the final, but they're there. Then for module 6 to 7, I'm not going to, it's going to be 20% module 6 and 7, but no hypergeometric or Poisson. Just learn those in a relaxed way. You don't have to, won't be testing you on those. I might have some quiz problems for them, but I won't test you on those. Module 8 is where we are now, or we're heading this week. Everything, okay, so it's starting to build up. This is 30% of your final exam. And you can omit continuity correction factor. I'm not going to test you on that, but you should learn it. And then module 9, the exam is 40% module 9. Now, module 9 material uses lots of stuff, lots of material from before. I do, again, for completeness, have some material here on inference of two population parameters, but I'm not going to test you on it. It just doesn't fit. It's a lot of material, and I want you to be good at the foundational stuff. That's my approach. But you should feel confident. The idea is to build your confidence so that you could comfortably read something like these pages and be able to solve problems like those as well. The format is going to be 16 multiple choice questions for 24 points out of 60. 5 short answer problems. You choose 5 out of 7. And then one problem, the reason why I'm showing you this, one problem is going to come from where we are now in modules 6 and 7, pages 42 to 48. So this is the concept of rules of means and variances. How many of you got that far to the rules of means and variances? Show me if you got that far. Otherwise, I'd like to review that. No one got that far? So that's where it's all headed, because that's going to be 6 questions, 10% of your final exam. All right. Okay. I want you to tell me if you did, because most of you are going to say you didn't. So nobody did, because you guys would be bragging if you did, right? So you didn't. All right. No. Okay. All right. So you need to work on that this weekend, right? So let me get you started on that. Is there anything before this that you'd like me to look at? I'm going to go to page 42 to 48. So just to remind you, I got this from module 9 at the very bottom, approximate distribution of the final exam. It does say the 9th, Alondra, at the top. Is there confusion? The exam is on the 9th. I want you to review inference by the 2nd, but you probably won't finish by then. But the exam's on the 9th. You guys don't remember the rules? I explained, just like the midterm, you're going to have 3 days. Schedule's right here. I guess you're just questioning the schedule. It's right here. Oh, okay. Okay. All right, so you ready? Any other comments, questions? I know I seem crabby. Lately, I've been really crabby. Just ask your questions. Don't worry about me. I just find I'm very snappy lately. I surprise myself. Any other questions? Anything before pages? Okay, so some of you didn't get to 30 yet, you said. I think you can do that comfortably without me. Well, you have my videos. So let's, and what I'm going to say now is also in the videos, but I think this is a good point to give you some hand, hold your hand a little bit through this. So let me go back to 6 and open this up. Oh, this is already open here. Okay. So Bayes is not on the exam. But I teach it in the videos. I think it's very important to know. Very useful. And for real life and for research, reading research. Okay, so you guys see the notes right now? Oh. All right, so I'm gonna go scroll to here. Rules of means and variances. And I cover this in the videos, like the review videos on the platform. Like I basically read through these. I don't know. I'm not very animated because I just wanted to get through them, but see if I can bring them to life. Module 6 problem homework file problem 9. Okay, Paula, I'll look at that. Let's look at that first, and then I'll go to here. Um, Having issues with my spacing here. Okay, so homework number 9. Okay, many random number generators allow users to specify the range of random numbers to be produced. Suppose that you can specify the range is to be all numbers between 0 and 2. Call the random number generator Y. Then the density curve of the random variable Y has constant height between. So what's the issue here? Can somebody, so it's very wordy. What are they getting at here? So this module was trying to help distinguish between discrete and continuous distributions, and I taught you a new continuous distribution, the uniform, and I taught you specifically the discrete distribution to identify the binomial. So what is this? So broadly speaking, is this continuous or discrete, this Y? Is it continuous or discrete? Put it in the chat. Uh-huh. It's continuous, right? Because all the numbers between 0 and 2, well, if it was discrete, there would just be the number 1. So that should make you feel like, oh, okay. They're talking about continuous. All right. So now that you know it's continuous, and that what they're describing is what kind of distribution that we learned about. What continuous distribution? So go back and review, right? I taught you about well, we learned about the normal. We're going to learn about the t distribution, and the other continuous one that I described in module 6 and 7 is the, Jordan is right, uniform. What is the uniform distribution? It's a box. It looks like a box. And it's basically saying that, you know, this is not the right way to say it, but every value is equally likely because it has the same equal height, but that's not how you interpret it because you can't have density at a value, but any range of values is equally likely. So I explain like people who study a little bit for an exam. I use that example. People who study 0 to 4 hours, the chance of people studying 0 to 4 hours is just as likely as people studying from 16 to 20 hour. No, I said I think I used 8 hours of sleep, so it was 16. So like 12 to 16 hours is 4 hours difference. So that it just spreads it out that every observation or every value is equally likely. It makes a box. So what you have to do is make a box. Do you want me to do this? I can do this. It's easier than using my hands. So this is described in the videos. Most things are there. Um, so we make a box. Now, the reason I know I can do this is because the way that it's worded. What does it say? It says it has a constant height, right? That makes a box between 0 and 2. So, well, it's not gonna work. Didn't work. Let's make a box. Make a box. This is 0, this is 2. And we want to find the area between 0.6. So if this is 1, this is like 0.5, and this is 1.5. So you want it between 0.6 and 1.7. So it's going to be length times height, or width times height, or height times width. Let's do alphabetical order. Height times width. Let me get rid of the X. Okay, what is the height? So X is distributed uniform, and all you use are the upper and the lower. Sorry, that's not upper. The upper and the lower limits. The lower. And this is the upper. So in general, X is uniform, L, U. All right, so then what was my question? My question to you was, what is the height? The width, I know. The width would be 1.7 minus 0.6, which is 1.1. And what is the height? How do we figure out the height? So for this to be a density curve, the area of the whole thing must be 1. What's the width of the whole thing? There's a lot of W's floating around. This W here is just the width here, but this entire width is equal to upper minus lower, which is 2 minus 0, which is 2. So I know the width is 2 of the whole thing. And I know area, which is equal to height times width of the whole thing, must be 1. I don't want to put any special symbols. Hopefully you know what I'm talking about. So the whole box, so the height of the whole box, I don't know, that's my question. The width is 2, and this is 1. So that means the height must be 1/2. In general, for a uniform distribution, the height is always 1 over upper minus lower. So if you have the parameter, these are the parameters. Parameters being like they help you draw it or express the distribution. It's all you need to know to draw the box and solve. So I have the height as 1/2 of the whole thing. And so the height is 1/2 and the width is 1.1 for this red portion. I'll do it like this. So that's for this red portion. So that's why it's 0.55. How's that? So that's something, it should be reviewed in the videos. If it's not, let me know. But that's the uniform distribution. So I teach you that. And I teach you generally how to deal with any shape. If this was a distribution, it's actually in the homework or the tareas. What if that's a distribution? Then you need the rule for area of a triangle, which I give you. What if this is a distribution? I give you the area of a circle, and you can figure out, in between things like that. Okay, so that's using principles of mathematics, geometry that you've learned before, but I give you the rules. I don't expect you to remember them. And then the principle that the density curve has an area of 1. So that's the statistics piece. The density curve has an area of 1, and this is just mathematics, arithmetic. All right. What else? What other questions? Okay. Anything else? No? Right, Jordan. You can use A, B, you can use lower and upper. Mhm. All right. Number 15 from Paula. That's a good number 15. I closed it, but it's fine. 15. Hmm. Okay, so this actually is kind of getting to what I'm going to talk about next, right? You guys want to try number 15? Well, you have to do 14 first, or use the information from 14. Are you trying it? Just give me a second here. Um, oh, I skip over that. Okay. So at the top, at the very top of well, close to the top of your course are all the homework solutions except for probability because I added it after I did those solutions. How funny. All right, so I would do this the long way because I'm not sure if I did it any other way. So what you have to do is imagine you have to okay, so let's yeah, you guys can put your ideas in the chat. I'm gonna do this the long way. If there's a shorter way, I'm sorry. But I can't think of it right now. So you're gonna see my iPad. Are you watching my iPad? Okay, so
Yes.
okay, so this is the these are the two die. This is die, well, the first roll, right? Roll one. This is roll two. And so these are the possible outcomes, but I have to add one, right? So then this is adding one. So these are the possible outcomes here. Is everybody getting that so far? I'm going to go first from first principles. I have nothing else right now. So let's make the probability distribution. What are the possible outcomes? What are the possible outcomes? Three, four, five, six, seven, eight, nine. 3, 4, 5, 6, 7, 8, 9, right? Now, what's the probability of each of those? There's 4 times 4, 16 possible outcomes. And so what's the chance of 3? 1 out of 16. If you guys don't like fractions, it's not a good thing. If you need help with fractions, that's a whole nother ball game, but I'm going to use fractions. It's possible that you don't like fractions and you might want to use decimals, but it's really hard with 6s and 3s because you're going to get repeating decimals. Okay, so 116. What about 4? What's the chance of 4? Right, 216. This should feel familiar if you watch the videos already. The 5, 316, 6, 416, 7, 316, 8, 216, and 9, 116, and they should all sum to 16 16s, right? How do we get the average? How do we get the average of that? How do you get the average of that? Nobody? What do you do? How do you get the average of this information? So you guys didn't get that far yet. So this is a distribution. It's a discrete distribution. To get the average, you have to get the weighted average. Does that help at all? Remember when we had, okay, it looks a little bit different, but remember when we had this? What do you do there? You remember this? Right? Weighted average. That's what you do. But in this case, the weighted average, because this is the whole distribution, not just outcomes, we're going to call this, mu. This is actually the population distribution because these are all the possible outcomes. So it's going to be a weighted average. And I'm not going to use lowercase. I'm going to use uppercase to show that, those are all the possible outcomes. Anyway, so you have to multiply. You multiply, and add all of these, and that's your answer. I'm surprised I gave a question like that in there, but that's how you do that. All right, so once you do that, let's take a break. Let's take 10 minutes. Let's meet again at 10:15 and we'll talk about that. But you guys can take a break, get a snack, work on that, think about it. Okay, so let's break until 10:15. So there you go. Okay, I'm back. A little bit early. Oh, you did some calculations? All right. I feel like I'm doing this a really long way, but um, I don't immediately see any other way. Nice of me to put none of the above. Let me see what the answer is. Oh no, I won't look at the answer. I will wait. So the weighted average is 3 times 116 plus 4 times 216 plus 5 times 316 plus 6 times 416 plus 7 times 316 plus 8 times 216 plus 9 times 116. Did I make any mistakes? So then it's going to be 3 plus 8 plus 15 plus 24 plus 21 plus 16 plus 9, all out of 16. What's that? I can put those all into my calculator. I don't know why it's opening that. I'll just do it on my phone. Um, all right. How many people did this? You can brag in the chat. Do you see the logic? Do you remember this? This is like I did over here back when we did weighted mean and weighted standard deviation. Very good. 666. And the answer is 6. All right. So that is a process. And that leads very well into what we're doing right now. We're going to do next. Okay. So we need to make the probability distribution from scratch. Following the directions, sum the rolls. These are all the possible outcomes. And then add 1 to all the possible outcomes. Then count what's the chance of each possible outcome from 3 to 9, because those are in the chart of possible outcomes. Then find the probabilities of each, or write the probabilities of each that must sum to 1. Let's verify. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. And then you multiply them to find the average. All right. Okay, I'm going to leave you to do the standard deviation now. Look at your notes, think about it. You guys can do this. You just endurance. It's just a matter of endurance. Sometimes students have endurance and they become very creative and they solve a problem for pages and pages. You don't need pages and pages, but most of the time it's, basic principles with a little bit of endurance. If you have pages and pages, you did something wrong. Okay, how are we going to do the standard deviation? Let's see. We're going to use this as well. We need to remember the formula. There's actually two versions. Let's see what I put in the notes. There's like a couple of versions of standard deviation. So what I used was this, you guys. That's what I used. Means. I did this. It looks a little bit different here because I didn't say X and PI. I used the notation from discrete distributions, but that's exactly what it is. It's a discrete distribution. And then, okay, so I skip a few pages to talk about rules of means. Then I do the variance. So this is the formula for variance. Okay, so there's these two boxes. You can calculate the variance this way, which should remind you of the weighted variance formula. Or you can calculate it this way, which is very handy. So these two boxes, they're both useful. Which one do you want to use? Which one do you want to see? Probably the first one, because we did that before. If you do it the second way, you can actually do this in your finance. I mean, in the finance calculator, the TIBA 2 plus, we could actually do this. I think it's an output in the regression. Let me check. Check in the data. In the data sheet. It is, but it's the mean of x squared. It's not the sum of x squared. Might get confusing. Okay, so let's just use the first one. Did you guys all do it already? You all calculated already? Who wants me to calculate it if you did it already? Who wants me to do this? All right, let's move this chart like this way because this feels like more like Excel and more it's a little more comfortable. Let me just in case someone's asking where did I get those numbers from? I'm just saying as an example, recall. All right, so we're going to take these and make columns with it. I'm going to take it on another page. And we're using the Greek letters, remember? Because this is like a distribution. I feel like I'm going to have to abandon my fractions. It might not work for me. Okay, so what I have to do next is x minus mu. And the mu, so it's, x minus x bar, in other words, right? So the mu was 6, remember? So that's going to be -3. That's going to be -2, -1, 0, 1, 2, 3. And I have to multiply by p in the next column. Sorry, my lines. I'm going to get my ruler out. Oh, that didn't work. Let's get my ruler. So x minus mu times the probabilities. Oh, no, I have to do square, right? I have to do square. So do you guys see how that is the same as the formula? What I just did? Sorry, it's so messy. So I'm going to do x minus mu, square it all the way down and multiply by the probabilities and then sum. And that's my variance. That's my variance is a total. There's a square here. So this is 9 over 16. This is 4. Okay, I gotta make this bigger already. Let me clean up. So this is 9 out of 16. This is 4 out of 16. This is 1 out of 16. What I do? 4, yeah, and that's 3. So that's going to be 8. I'm forgetting to multiply. So it's going to be 2 squared is 4 times 2 is 8 out of 16. And then 3 out of 16, 0. Remember to square here, so that's just 1 times 3 out of 16. And then square this, 4 times 2 is 8 out of 16. And then square this, which is 9 out of 16. And sum them up. Is that what you guys did? And then add them up. So if you just add these and then times by 2 because it's repeated, right? It's symmetric that way. So this is 20 out of 16. No, is it 20? 17, 18, 19, 17, 18, 19, 20, 20. 40 out of 16 is the variance. So what is 40 out of 16, by the way? That's the variance. So what is the standard deviation, my friends? Question was the standard deviation. Let me go back. Okay, let me stop share. So the question was find the standard deviation. So it's going to be 2.5 square root. Okay, so that's not hard. It just takes endurance. Gotta never give up. Finish the problem. Answer the question. So it's none of the above. Is that possible? Is that correct? 1.58. The answer should be E. Let's see. D. D. What did I do wrong? 15. 2.2. Okay, let me double check. What did I do wrong? I might have done something wrong. 2.2. So nobody got 2.2. Let me see. I wrote this correct. X minus mu. 3 minus 6 is minus 3, right? minus 6 minus 2. And 9 minus 6 is 3. And you square them. 9, 16, 8, 3, 0, 3, 8, 9 out of 16. 17, 18, 19, 20, 40 out of 16, 2.5. And square root. Well, we got 1.6. I don't know. I kind of stand by my result. Did I make any mistakes anywhere? Anybody can detect? One 1.58, 1.6. Everyone has different. No, Patricia. Nope. I don't think. No, I mean it's possible that the clave is wrong. Let me check. I like what we did. I defend what we did. Unless there's something. The mean was we did get 6. We had a mean of 6. Gotta go back there. I'm gonna double check my calculations. 24, 21, 9. Let me just stare at it for a second too to see, which makes sense, right? Because it's in the middle. Even visually, it makes sense that it's 6 because it's in the middle and it's a symmetric distribution when you stare at it, right? So that would be the balancing point. So that makes sense. And then standard deviation should be, let me just double check that I'm missing something. I think I did it right. Okay, well, it's possible that's a typo. Should be none of the above for this deviation. None of the options match. I had the exact same result. Variance 2.5 and deviation. Okay. All right, so let's say problem 15 is a typo. I'll put it as a note. When there's none of the above, I'll give you a hint. If when there's none of the above, it's because I took I took a problem from somewhere and I made it up. I changed an old problem and I didn't have time to solve it. So I put none of the above. And it could be one of those, and it might not be one of them. So it could be, this is a long time ago that I made that problem. So um probably at least 10 years ago. I don't remember. Even where I got it. Let me check one other thing. All right, so this is a good review or intro into what we're going to talk about now. I'll just make a note. I'll put it on the I'll put it right by the homework and just say prob 15 in homework prob. Mhm. All right. Okay. Any other questions? It was a good one, and it was good timing. So I'm gonna get into back into the notes. All right, so we looked at these. So in these notes that most of you didn't get to yet, that's what we do with it. Okay, so I review or I talk about the idea of discrete distribution and calculating the mean. And I do it I prove that I prove a number of results about transformations of distribution. So this is a distribution that's given. We just practiced with an exercise where I gave you a distribution and you can calculate the mean from it, doing it like this, a weighted mean. And this would be mu because it's a distribution of a population. It's not just a sample result, right? And so we can get the mean, and then I skipped over all of this, and I'll talk about that in a second. Then I went to the variance notes, and that's on page 39, and reviewed how you calculate the variance. And I use the symbol sigma square for variance of the variable x. And then there's also this way to do it, which can be handy. That can be handy because you can get that out of your calculator, kind of. And I actually show this, I solve for this using the formula. Okay, using E like what's called an operator. I didn't write that actually. Okay, so when you stare at this here, remember I told you way back when we talked about weight and mean, I said whenever you see a summation sign and divided by n or n minus 1, it's usually just a mean, right? We refer to that as a mean. So also when you see the summation sign and multiplied by a p, that's also an average. So statistics is about averages and relative measures. Here's a relative measure, the deviation from the mean, and here's the average because I'm summing and I'm dividing by like I'm giving them all each observation, or in this case each value, a certain weight, so it's a weighted average. So this is also an average here. It's average of the squared deviations from the mean called the variance. And because it's an average, look how I write it. It's the average E, or expected value, of the deviation from the mean square. So I go through and I square it. If you guys remember how to do that, a factor, use the factor and expand it into its product. And I simplify. So I'm not going to ask you to prove any of these results, but they're very handy. And I use them to develop other results. All right, so those are the two, those are the main two boxes, right? Is the mean and standard deviation or variance, which you take the square root of when you're done. There's also this version, but I don't use this too much. But it's important to know that. What I want to do with this is talk about what if I take a distribution and I change it. One second. Like here. So we have these, right? 1, 2, 3, 4 were the possible outcomes. And each was equally likely. But then we created a new distribution with them. And that distribution was created by adding together the outcomes on the die and then add one more. Sorry, there's some feedback. Make sure you have muted or it's going to echo. All right, so we created a new distribution of the one that we already know. If we created a new distribution in a specific way, we don't have to derive from first principles like we did. We took some time, we made the matrix, we calculated all the possible outcomes, we calculated the probabilities, and then we calculated the mean and standard. We don't have to do that if the new distribution is created in a certain way. Does anybody know the certain way I'm going to create the new distribution? Anybody get to read this far or know what happens next? The way we're going to create the new distribution is transform it in a linear way. That's what it's called, linear transformation. We're going to take the original distribution. We're going to multiply every value of that distribution by a number. It could be a negative, could be a positive, could be a fraction. We'll call it B. And then add or shift that distribution with a number A. We're going to add or subtract. So we're going to move that distribution around. If we do that, that's called a linear transformation. And we don't have to start from scratch. We don't have to remake the distribution. It's a simple rule to remember: whatever you do to X, you do to its mean. Whatever you do to X, you do to its mean. So look at the mean. I'm also going to multiply the mean by B, and I'm also going to add a shift factor to it. So this becomes useful. We don't have to do things from first principles. We don't have to start all over. I took the time to prove this to you here, which you don't have to memorize or know, but you can read through that, I hope. And then we're going to apply that principle. So what I'm going to do, if you guys are okay with it, did you understand what I just said? So whatever you do to each value of a distribution, you also do to the mean. This is true for discrete distributions. It's true for continuous distributions. So I actually do some illustrations to demonstrate all of this, and I recommend you watch those illustrations. And I do some mathematical things here. I think it's better with the drawings personally. But what I'm going to do is scroll to here. We are going to apply that idea here in a practical way. So here we have a problem. Each year, employees of a large company receive a Christmas bonus of $500. Plus $100 for each year they worked for the company. Okay, read that and tell me, what is the shift factor and what is the multiple? What are we multiplying by? To create the new variable, we start with the number of years. That's the base variable. And then we convert it to a new variable to find the Christmas bonus. So what is the multiple and what is the shift factor? $100 for each year. So per year, that's the multiple, $100. And the shift is everybody gets 500 bucks. So 100 is the multiple, and we call it a scalar multiple. And then we add, that's the shift factor. And it looks like a line. That's why they call it a linear transformation. It looks like a line, but we're not going to draw it or anything. We're just, the idea of, of a multiple and a shift factor is a line. All right, what are we going to do with this? Whatever we do to every value, we also do to the mean. So they tell you that the average employment, the X, is 6.7. From that information, what is the average Christmas bonus? How will you figure that out? So that's the average. So I'll write it all up formally, but I want you just to logically think about it. Because this is like a lot of text, a lot of notes to explain like a simple concept, unfortunately. And I just want to cut through it all, and you'll be able to read through this much easier. Notice it doesn't matter what the distribution of X is. I don't say that anywhere. I say X is the number of years of employment. Okay, number of years working, right? I'm going to show my thing in a bit. I'm asking you, you're supposed to find for me what is the average Christmas bonus if the average number of years or average duration of employment is 6.7 years. Yeah, I'm going to switch to my iPad. Everybody wrote the question down. This is from slide page 42. So I really jumped ahead just to get to the point of all this before you go for the day. Unless you have other questions. Okay, you guys got to the question. Can I go to my iPad? Because I'm going to ask you some questions about it. Okay, so there's my iPad. The mean of X, I'm going to use the notation. The mean of X is what? And what is the standard deviation of X? What's the mean of X? X is the number of years as an employee. What's the mean of X? Good, good. Okay, so everyone's awake. 6.7 years. And what's the standard deviation of X, the number of years of employment? Standard deviation of X is given, so those are given. Now we need to find, question is find y, mu y and standard deviation of y. Find mu y and find standard deviation of y. How do we find mu y? So mu y is the same as EY, or expected value of y. And I'm going to use the operator to go through this whole thing here. Going to move this aside. So then what happens is, what I said to you before was anything you do to X, you also do to the mean of X. So this pattern, you can think of it, it's just replaced. I replaced this with the mean of X. Or you can say that E, the operator, does nothing to 500, it just comes out 500. And the operator does nothing to the 100, it just ends up like that, which is 500 plus 100 mu of X, which is, you know, a few extra steps and some notes to say the same that I said before. Whatever I do to X, I also do to the mean of X. And like I say, I encourage you to watch the video where I do all the drawings. I'm not going to do them again here. So illustrations to show you. So this is 500 plus 100, and then you put in the mean of X, 6.7. So we didn't have to go from scratch like we just did in that exercise that took us a half an hour. All right. We don't have to do that. We don't have to recreate from first principles. We're just going to use the rules of means and variances. So this is 500 plus 670, which is 1170. Okay, so that's it. Questions about that before I go on? So I write it as mu of y. I also write it sometimes as a plus bx. And in this case, a is 500 and b is 100, right? I don't know, whichever method you like. I just need you to remember the principles. Okay, so now we're going to do standard deviation. So what's the rule for standard deviation? I didn't even get there yet. So let's go back to the notes unless you have a question. I didn't talk about that yet. So let's look at the notes. What does it say about standard deviation? Okay, I'm just going to scroll up. So the notes are first, an introduction to means or a review of means. And then I talk about the properties for means for discrete and continuous distributions. And I focus on, I illustrate with discrete distributions, but you can do the same thing with with continuous distribution. So there's two properties. One is the transformation that we just did. Another one is, does anybody know? Sum and difference, the mean of sum and difference of two variables. So look here. What does this say? How are we going to repeat this? The mean of the sum of two variables is the sum of the means, right? The mean of the sum of two variables is the sum of the mean. This is very useful if you think one good example is if you have like an investment, you've invested in two assets, X and Y. They could be stocks, they can be different securities, they can be two investment projects. And this is X represents the returns, to that investment. The average return of holding both of them is just the sum of the averages of the two investments. That makes sense. And then I just write like that. So mu X, mu Y is the same as EX, EY. Also the difference, if you have two variables, you subtract them from each other, the difference of the means, the mean of the difference of the random variable outcomes is the same as the difference of the means. Okay. So those are the rules there. All right. So now we're getting to talk about, so I give you a bunch of examples, which you should explore, time permitting. And here is the rule for variances. This is how we calculate variance. We already discussed that. But what about the rules for both the linear transformation and the sum and difference? What do we do there? So I'm going to focus more on this version. The truth is, for the variance of a linear transformation, this is the result. Can anybody explain why? So for the mean, it was whatever I do to the X, I also do to the mean, but something happened here. What happened in particular? What are the two main things that happened here in the transformation? If I use variance as an operator, like I used E, I try and use variance. What are the two things that happened? Nobody can see it? Okay. Nobody sees it? All right, so the variance of a plus bx is not a plus b variance of x, right? Like like it was for the mean. It's not like that. First of all, we lose the a because the answer is, I'm going to write var because that's what I did in the notes. Okay. This is not the same. First of all, I lose a. A is gone. Why is a gone? Well, think about it. Let's say this is my distribution, x, and this is like a think of this as a number line. And let's imagine I'm going to shift every value. I'm going to add 10 to every value of x. What's that going to do? Well, it's going to shift this over x plus 10. Oh, let me erase that. Right? It's just going to move over. Did it change the variance? What does variance mean again? The spread. It's a measure of the spread. So the shift factor does nothing to the variance. That's why it falls out. It disappears. So it does nothing. But why is b squared now? So the multiple will change things because if I go from x, actually I'll paste another one of these. So what if I multiplied x by 2? What would happen? What would it look like? What would 2x look like? Let's say this is 0 here, or let's make it like 5 and make that 10 and make that 0. What would 2x look like? What would happen to those values? That means multiply 0 by 2. What does it become? So that would still be 0. What's 5 times 2? 5 times 2 is 10. And what's 10 times 2? It's 20. So the same data that's between 0 and 5 has to be between 0 and 10. So this flattens, it spreads it out more and flattens my curve. You guys see that? It's supposed to be flatter. I'm making it flat, but it has to go there. There. Okay. So it needs to still be symmetric. It doesn't change the shape, but it changes the spread. This is the peak. The peak has to be flatter. So I'll make it half the peak. And then, anyway, should be more curvy. I hope you understand what I'm saying. Okay, so 2, it spreads it out more. But why is it squared? So that stays, that does affect it. But why does it get squared? Because when we do the variance, remember every deviation from the mean is squared. So also the weight gets squared. You'll see in the videos how I explain that, okay? So what we really want is the standard deviation. So I'm going to erase this. This is the rule. So if the variance of a plus bx is b squared sigma x, what is the standard deviation of a plus bx? Or sigma y, where y is equal to a plus bx. This is going to be b squared sigma x squared, but the square root of it. Okay, so this is the variance because it has to have squares on it, but this is the standard deviation. So that's why it's squared, because all the values are squared, all the deviations from the mean is squared. So this weight gets squared too, or the thing in front, the scalar. Okay, so the two things I've shown you is shift doesn't matter with the variance. It doesn't change the spread. The multiple does, but be careful if you're getting the variance, you have to square it just like the standard deviation is squared. And then to get back to the standard deviation, you have to take the square root of that, which is sigma y, which is b sigma x. Let me put all these notations in because this is what I want. So I explain all this in the video, but the main thing to realize is that there are two formulas here. This one is the easier one, right? But it comes from this one over here. All right, so back to the question. What is the standard deviation of that transformed or that bonus, the Christmas bonus? What's the standard deviation of the Christmas bonus? Okay, you guys all did it. All right. We did something. Okay, so the standard deviation of the Christmas bonus. So those are the rules. Those are the main rules. I still got to show you another rule before you go. Another couple of rules. So we want the standard deviation, which I showed you was B sigma X. So all you have to do is take the shift factor and multiply by the original standard deviation. So the shift factor was not shift factor, multiple. The multiple 100 times sigma x times 2.4. So that is going to be very good. 240. And these are dollars. Questions? So you got to remember those rules. You can begin assembling all your formulas, onto a document. You'll see that this week when you start studying module 8, I give you a formula sheet and I actually teach you how to use it efficiently for the remainder of the course, the next few weeks. So you can add formulas like these ones to that. The formulas being mu A plus BX equals A plus B mu X, and sigma A plus BX, creating a new variable Y, is going to be B sigma X. It's very simple. In the end, after all this notation and all this hard work, it's quite simple to make the point. But that's the idea, right? These are complex concepts that have been developed, like the teaching, the pedagogy of it has significantly simplifies things for you. It's accurate, but it seems, easier to understand in the simple terms. Now, why is this possible? I have many proofs to show it. Oh, that's not square, sorry. I'll put a square. That's just B sigma X. I have a bunch of proofs to demonstrate why this is. You don't ever have to prove them. You just have to know the results. So this one says the mean, whatever you do to the X, you also do to the mean. So the X gets multiplied by B and added with A. Well, the mean gets multiplied by B and added with A. And as for the standard deviation, the shift does not affect the variance or the spread of the distribution. Only the shift factor does. And that's it. You need to remember that the variance is, because we're going to talk about covariance. So I also have the notation for sigma squared A plus BX is equal to B squared sigma X squared. That's also true. It's really since this is true. Okay. The last thing about this I want to show you or point out. So anyway, we did a problem. You guys, we did a problem. We're breaking into this material. It's not hard. It's feasible. That's the important thing. And I'm going to go back to the notes. Okay, so this is for variances. This is a rule, and this is for standard deviation. Then I have some practice problems with discrete distributions. I prove it. I basically prove it here. I do it the long way, but you don't have to. If you know the rule, you don't have to do it the long way. Okay, so this is the second thing about variances you need to know. I'm going to make this big. Remember, for the mean, I did the sum of means is equal to the, sorry, let's go back. The mean of the sum of two random variables is equal to the sum of the means. The mean of the difference of two random variables is equal to the difference of their means. What about variance? So I'm going to take two variables, X and Y, and I am going to find, is it easy enough just to calculate the variance of the variables added together? So let's say I have two assets or two securities and I'm holding them as investment. Is the variance of holding them together the same as just the sum of the variances? What do you think? So we're going to interpret like variance, or when we talk about finance, usually, well, we refer to the variance or the standard deviation or the spread as the risk. Is this true? This thing in the box? Who says it's true? Who thinks it's true? It's in the box, right? It should be true. So if you hold two assets, the risk on your returns from holding them measured by the variance is just the sum of the two variances. Okay, so you guys don't know if it's true or false, right? Okay, the fact is, if you hold two assets and they are not related, this is true. If they are independent, in other words, this is true. Okay, so variances are added for both the sum and the difference of two independent random variables. If they're independent. What does independent mean again? If knowing that one occurred, it doesn't change the probability distribution of the other. There's no relationship between them that way. Okay, but that's not necessarily the case. They could have a relationship. What if two variables or assets, they have a relationship, like when one type of asset or one investment does well, the other one might do poorly. You can hold, in fact, that's how portfolios are made, to be diversified, that when one does well, the other one does poorly. There's like a negative relationship, negative correlation between them. That's how they hedge against risk. So what if they are related? Like, not that one causes the other, but they're correlated. Okay. Oh, one other thing before I go to the next stuff, why is this a positive here? This is a really important thing. Is that a typo? Who's going to tell me why that's a positive there? Is it a typo?
Does it have to do something with the absolute value?
Not absolute values. You're onto something there.
It's squared, so either way, it's going to be positive.
Yay, you got it. So because of the rule was when I do the variance, remember that it gets squared. So what's B? When it's a negative in front, the negative comes with the B. Okay, so that negative B gets squared. Exactly. So here you imagine there's no B, you don't see a B, but it's a 1. It's a negative 1 in front of the Y. What's negative 1 square? Positive. All right, so it adds. So that's not a typo. That is correct. So I made it simple here. I just use X and Y, but I could put AX plus BY, which I will do. I will do that. And we can talk about this more next week as well. But I want you to practice with it. Okay, so you guys believe me about this. This is true if the variables, random variables X and Y are independent, not correlated, in other words. But what if they are correlated? Then the variance formula changes. You have the first part, X and Y, but you also have this other term. And I explain in the video, I don't think I have time to do it now, that this other term here, 2 covariance X, Y, where it comes from. It comes from thinking about the contribution to the variance or the risk of X and Y, X with Y and Y with X, and then X with itself and Y with itself. It's really, that's where this comes from. And this crazy looking formula here comes from there too. I guess I better show you. So all of this stuff is not hard, okay? It looks really confusing and hard. I'm using my Greek letters, but this is variance, variance, and this is 2 covariance. at the risk. Okay, I don't want to confuse you because I do go through this in the video, but basically this comes from, and I'll show you here quickly before we go and I answer your last questions. We're going to use a matrix. Now, if you're good with patterns, you can do statistics. All these patterns that I keep showing you. So if you're artistic, creative, you like patterns, it's good. If you're good at math, you can be good at statistics and get away with it even if you're not great with patterns. But if you're not good at either of them, I don't think that's possible. You got to be good at one of those things. You're going to make it through. All right, so here is what we're going to consider. We're going to consider a new variable called z. Oops. Z, which is ax plus by. And I want to find the mean of z and the standard deviation of z. Let's put z. All right. Also, let's work with the variance of z. That's a square. So what we're going to do to look at the variance, because we know how to do the mean, that's not hard. We're going to take each of these as a pair and find their covariance. Covariance of ax with by, covariance of by with ax, covariance of by with by. All right, that's what we're going to do. Those are each of them contribute to the variance of this new variable ax plus by. A could be it's a scalar. It's a number that you multiply by. So it's continuous number. It could be -1. It could be 1/2. It could be 3/7. It could be 30. I'm just going to use A for the general case. Now, looking at this, what is this? What is the covariance of AX with AX? If you remember the discussion of covariance back in Module 5, this is, I'm going to use from samples, right? I just think it's easier to look at the sample covariance of two variables. So this is actually going back to Module 5 because we're talking about X and Y. Even though we don't have a line per se, we're talking about two variables being related. And what do I do? This is, okay, what this means is AX minus AX bar with AX minus AX bar. That's what that means. And let's do another one. Let's do AX with BY. We're going to simplify further, but this is for now. And this is all explained in the notes. If you don't get it now, I mean, in the videos, it's okay. Okay, so stare at those and we're going to simplify them a bit. And then we're going to put it back in here. And basically, we're going to add all these together to get the variance of Z. Because that's the variance. So my question is, what do you see here? How can I simplify this? Are these the same? Are these deviations from the mean the same? Yes, they are. And it becomes a square n minus 1 times x minus x bar square. So this is really equal to who's going to tell me what this is equal to? What is this? Hey, great. Patricia sees it. That is the variance. So this is just the variance of x, and we write it like that with the a square. Look at that. I hope you see that pattern. That's where the square comes from, guys. The square comes from doing this. When there's a multiple in front for the variance, it has to go in front of here for every value and in front of the mean. And that's how you end up getting the square. All right, so this means a squared sigma x squared. And now try and do the same thing down here. Let's see if I can make this look familiar. I'm going to pull the a out of here and the b out of here and pull them in front. And then minus n minus 1 on the bottom. And x minus x bar, y minus y bar. Now what do I have? The covariance of a variable with itself, or the multiple of a variable with the multiple of itself, is just the variance. But the covariance of ax by gives you still what? What is this? Got to go back and see your module 5 material. Go back to module 5. That's called the covariance. That's the covariance. Remember, we standardize the covariance to get the correlation, but that is the covariance. So this is equal to AB covariance of X and Y. That's what it is. And that's how you calculate it if it's for the sample. If it's not for the sample, you have to do it times P, right? All right, so you can replace all of these. This one is equal to a squared sigma x squared. This one is equal to b squared sigma y squared. And each of these are what? What are these? AB covariance xy, which I'm going to write sigma xy, which I did back in module 5. So I showed you this stuff before. Now we're going to use it. I showed you these formulas. But go back and review. And this is also AB. So you notice in statistics, we do things in alphabetical order mostly. So this one with AX and BY is the same as BY with AX, right? It doesn't matter if I reverse the brackets. So now that you have this, you see the formula that I showed you. If X and Y are not specially independent or anything, they're somehow correlated. I'm going to write that. You ready? A squared sigma x squared plus, tell me the rest, somebody. B squared sigma y squared plus What's the last term? This AB times covariance XY and two of them. That is the formula that I just showed you. And that's where it comes from. If you go back to module 5 to remind yourself what this looks familiar, should look familiar. Also should be familiar that the correlation of X with Y is equal to the covariance standardized. So I use these formula and ask you questions about variables that are linear transformations of other variables or sums or differences of other variables. Okay. All right, so I showed you where the two comes from. I derived the formula, principle, and now you're going to apply it. We have 5 minutes left. So I'm going to show you what you can do with all this. Okay, first of all, are you guys okay? You're trying to copy it out, just take a screenshot for now, but you'll see it's in the videos and it's all over the notes, but that's where it comes from. And we can apply it in the problems after page 42. Here you have, so this is what this scary looking thing is about. That's all it's saying. This says, when you see this, the double summation, it means make the matrix, okay? Make the matrix where you look at the pairs, you look at the variables in pairs. So you can actually do this for more than 2 variables. You can have a long equation that I will show you. Everything I just showed you is captured in these boxes. They're all concluded in these boxes. So, for instance, where's my long equation? Look at these. So you could have 2 variables, you can have a negative here, you can have 3 variables. And you should be able, with the principle that I shown you, you can derive the long string formula. Okay, so you have the answers for all of these. I give you all the answers so you can practice. So what's going to be on your exam, your final exam, is a variation on one of these problems. I think I have 4 or 5 here. So I pick one of these and change the numbers around and you have to solve it. So you need to be somewhat, confident with these problems. Let's see how many I have. I think it's 4. So we just did one.
Professor, sorry, if you're projecting, I don't see your
Okay.
screen.
All right.
Mhm.
Thank you for telling me.
Yes, I also don't see it.
All right. So what I was saying is we just derived these formulas in the boxes. This double summation means make the matrix and take the variables as pairs. In pairs, you can solve this, and I do it in the video. I explain what this all means. Here is just for 2 variables. These are the results. This is the one I showed you just now, where I wrote covariance XY here, but it's sigma X, sigma Y. These are all the results I just showed you in the boxes. So we did this one already. You have the answer. That's 1. This is a second one. This is a third one where I've shown you can use 2 variables. You can use, remember, the negative here goes with the B. So that's a negative B. And here's one with 3 variables. I can have infinitely many variables, actually. And you have a portfolio of assets. You can have hundreds of variables. The index, the S&P 500, has 500 variables in it that they combine and they look at the mean and the variance. So sorry, I lost count. All right, so it was 1, 2, 3, and 4. Okay, so I give you 4 exercises. And I'm going to give you a problem similar to these that you will solve using the rules of mean and variances. Okay, and one of these will be on your exam. And like I said, your exam is 3 days. You have to do it just like the last time. Oh, here's the other one. Okay, 5 exercises. Okay, so you have an idea of what I expect from you, and that's for 10% of your exam. Your final exam will be solving one of these. So become somewhat familiar. That's why I spent some time now on this, so you're not wasting your weekend trying to understand what I'm doing. So hopefully with the videos and the review or introduction that I made today, you should be able to breeze through all of this and finish module 6 and 7. There's exercises in 7 that still use module 6 material. And this week you're going to start module 8. And 8 is it's very fast relatively. You should be able to finish it this week. Next week when we meet, I will work a little bit with you, just a little bit of review, and then we'll do some problems. And I will introduce the formula sheet that I'm going to use for the remainder of the course to help you, organize everything you've learned. I'm going to introduce the formula sheet, and I'm going to start inference next week. Okay, so we'll have 3 weeks of inference, hopefully, before the exam, because it'll be 1, 2, I guess 2 weeks. Yeah, you're going to have 2 weeks of inference. No, 3, right? Wait. No, you're going to work on binomial this week and sampling distribution. So work hard this week. And then, yeah, 2 weeks of inference. All right. So I'm going to have to introduce inference next week. So it's getting tight. You guys finish this weekend, finish this module 7 this weekend. That's my greatest recommendation to you to get through this. Okay. All right. Any questions? I'm going to just show you the formula sheet I'm talking about because I introduced it in module 8 and I use it again in module 9. I'll just show it to you. All right. So at the very back of the notes, the very end of the notes, what happened? Why does it do that? Actually, I think I have it on the platform too. So at the very end, there's this document called Selected Formula. And that is everything you're going to need to know for the exam. Most of what you need to know for the exam. I don't have the regression formulas here. I don't have a few others that you might want to add on another page, but we're going to work with this and you're going to understand most of this next week by the end of class. All right, and you'll see this also at the end of module 9. Patricia is asking me about the asistencia grade. For asistencia, I'm just going to take your top 5 grades and that will give you your asistencia grade, Patricia. Okay. I'm sure you're fine up there.
Also,
the new assignments that you posted on Connect, I can't see them. I don't know if other students have.
Okay, I'll verify Connect. Let me know if by the end of the day you don't see them. Okay?
Okay, thank you.
I'm gonna check it. Any other questions for me from any of you? No? Okay, don't be scared. Just work steady as you have been. The midterm is over, but you have to, you know, you have to have the same energy going into the rest of the class. Okay? And you're gonna be just fine. Okay. So we'll see you guys next week. Have a good week. Have a good weekend. Finish module 7. Send me any of your questions. Fill up the photo. Check the photo. See, because people have put questions in there. Not too many, but you can check that out and see my responses. All right. Bye for now.
Thank you. Have a nice
Thank
day.
you. Have a good
Thank
day.
you. Have a good day.
Bye.
Professor, I have a question regarding the final exam. In the midterm, I pass all the exercises handwriting. Is it necessary to write all the exercises in handwriting, or I just can
Just the answer.
take? Okay, okay,
Yeah, don't write the exercises. That takes too much
okay,
time. But let me know if you have any questions, even during the exam. Okay.
okay, okay.
Okay.
Thank
Bye,
you very much.
Carla. Thank you.
Bye.
Bye.